Hello, my name is Jonathan Guthrie, and welcome to our Getting Started with Perfect series. In this installment, I will be introducing the Swift ORM StORM, which has been designed to work with Perfect and its database connectors. I'll cover setting up a class to work with StORM and the basics of reading, writing, and deleting data. First of all, let's look at what an ORM is. Now, ORM stands for Object Relational Mapping, and is a methodology that is meant to provide a link between your objects and your Swift code and a database entry. It means that you can create and populate an object in code and invoke a save command, and it will save the record, updating it if it already exists. Otherwise, it creates a new one. Okay, conversely, you can then also instruct the ORM to get a specific row from the database, and it will populate the object, or if more than one row matches your find criteria, it will return an ordered array of populated objects. And lastly, an ORM will help you easily delete an entry. All of this without having to create all of the connections, handle all the database, open and close operations, and all of the other detailed code that is often required to handle database operations. That's all covered inside an ORM, so you don't have to. Now, the real magic of an ORM, however, is in two other concepts. If you are using a SQL database, you don't need to know SQL to make all this happen. And second, the basic operations and syntax should be pretty much exactly the same from one database to another. A get operation is the same as if you are using a MySQL database as it was with a MongoDB database. And that's the same with a save or a delete. Today, we're going to look at ORM operations in Perfect using the SQLite StORM. As I have previously mentioned, all of these operations will be virtually identical for the other StORM variants, MySQL, Postgres, CouchDB, and MongoDB. First of all, let's create a new project in Perfect Assistant. We'll make an empty executable project, and we'll call it StORM Demo. Now, this has no dependencies at all right now, so let's add the SQLite StORM dependency and then press Save Changes. Immediately, it will start fetching all these needed files and will recreate the Xcode project. Once it is finished, click the Open Xcode Project button. Opening up the mains.swift, the default is a print hello world statement. Let's run that, but first we need to select the executable target scheme. And while we're at it, we will set the project working directory, which you're going to need later on. Okay, so running this, we now see that hello world has been printed out in the console view. Then the program finishes. Unlike a web server executable, which keeps running until you close it, this executable is a simple run and exit. Now, this hello world isn't what we're here for. The first step is going to be defining the database configuration. For SQLite, we only need to set up one thing, the database name and location. For others, you will have to set up parameters like IP address, port, username and password, but it's a lot easier to get going with SQLite as a teaching tool. First of all, we need to add to our main.swift file the import for SQLite StORM and import for the base StORM library. Now we can add the SQLite config, SQLite connector.db StORM demo. Okay, so this tells the ORM that the location and name of the file is at the surface of our working directory, and it's going to be called StORM demo. The next thing we need to do is add a class, give it some properties, and hook it up to be used with the ORM. Create a new file for our class, monsters.swift. In this file, we don't need Foundation, but we do need SQLite StORM because we are going to use it as a superclass. So, class monster, SQLite StORM. Next, let's give the class some properties. ID, name, number of legs, and how dangerous it is, so danger level. Note that I've given the properties both a type and an initial default value. This is simply so that we don't then have to create an initializer and can dive straight into using it. We need to add a couple of functions as well. The first one, the to, describes how to interpret the values coming back from the database. This might seem redundant at first, but later I'll show you why. The next step is a simple iterator that will help the ORM make an array of our monster object out of multiple results. This is the rows function. Our class is finished for now, so let's go back to main.swift and get things started. var start equals monster, and we're going to try start setup. What we're doing here is we're creating an instance of the class so that we can run setup, which will check to make sure that the table monster exists in the database, and it will create it if not. In this situation, we're going to ignore the possibility of a fail, because for this, a fail is not necessarily wrong. Next, we're going to make a new instance, give the properties some context, and save it. The save has to be done in a do catch so that we can handle any errors properly this time. Okay, so thing1 monster, and call it Randall. 4 legs, yeah, it's moderate dangerous, and then we're doing our do catch with our save. Let's run this and see what happens. So we see that it's run the setup as we requested, it's saved it, and then it's exited. Okay, so it's saved, but where's the data? So for this demo, I'm going to use a free open source tool called DB Browser for SQLite, which you can download from http://sqlitebrowser.org. Opening the database in this, it shows you that there is a table called monster. Looking at the data itself, yes, there's the row with the data that we've just saved about Randall. Now there's one thing that's different, the ID column. We didn't set that value. In fact, we deliberately left that out. What happened is that the database itself gave it a value because in the setup function that created the table, it assumes the first property in the class is the primary key. And if it is of type int, it will tell the database to make that column self-assigning, and it will start at 1 and climb for every new row. That also means that if we don't assign a value, it will create a new row. In fact, if we rerun this, we will now get 2 Randalls. So back in our main.swift, let's add the ID property and assign it the value of 1, which was the row's ID back in the database. And let's crank up his danger level. Running this and looking at the database, yes, there's the data, and it's not been duplicated, it's been updated. That's because the ORM has seen that we've got a value for the ID, so it attempts to perform an update instead of making a new row. Let's make some changes to our class, adding an initializer and making it a little easier to set danger levels. Okay, first the init. So now let's fix the danger levels. We don't really want to have inconsistency in the data. It makes it harder to find things if someone makes a typo. So let's create an enum. So the enum danger levels, it's got case of none, tame, moderate, nasty, toxic, and lethal. Now we update the property for this class. We're going to make it danger level. Instead of being a string, it's going to be of type danger levels, and the default is going to be none. We can then change the init, change the to function, Now, if we go back to the main.swift, we need to also change the input so it's a value from the enum. Change it to .toxic, and then let's run and look at the data. Yep, there it is. The danger level is toxic. Let's add another couple of monsters now, and then we can look at delete and find operations. Note that after running this, I'm going to be commenting out the make new function call, because it would give us a lot of duplicates if we keep it in there for each run. But now that we have more than one record, we can do a find. To illustrate, we will find all the tame monsters. There we go, tame monsters. We've got Sully and Mike. Right, so let's make a new row in the database. Now we can find it, print the ID, and then delete it. So let's look back in the database and check that it's not there. We can see the entry in the console, but we shouldn't see it now in the database. We can also get a row if we know the ID. So we know the ID of Randall from the start. It was 1. So let's try this. And there we have it, StORM. It's not hard, is it? The great thing is that these same basic techniques work the same across all of the SQL variants, and almost the same in the NoSQL versions. The only difference is that NoSQL uses strings for primary keys, so we have to do things a little differently, but that's for another day. StORM is documented here at perfect.org/docs/storm.html. Go and check it out for a deeper dive. And also, for examples, please visit github.com/perfectexamples. There is an ever-growing library of examples and demo there. And of course, if you're looking for live help from our awesome community, please join our Slack channel via www.perfect.ly. Thanks for being with us today, and don't forget to say hi on Slack.